Hello everyone, welcome to this question where we are given that there is a house B which is 400 meter due south of A as shown in the diagram. Okay, so that's where the north arrow it is lah. The bearings of cafe C are 115 degrees and 41 degrees from A and from B respectively. From A, north arrow already drawn down there. From B, there's the north arrow also. And if we were to look at from A for this C, AC bearing is 115 degrees. So from the north arrow to the ending line, this is 115 degrees. From the north arrow to the ending line of CB, it is 41 degrees. Okay, and with that, find the length of the distance BC. Part A, it will be good if I know this angle here. So angle BAC will be equals to 180 degree minus away my 115 degree because they are adjacent angle on a straight line. And this will be 65 degrees. Okay, and so I would then be able again to get this angle here, which I'm going to use red color. So angle ACB will be 180 degrees minus away my 65 degree minus away my 41 degrees, because this is angle sum of a triangle. (74 degrees). And so to find BC, right, there are two ways to do it. Since we got all the angles, we could easily use cosine rule, or since we know one of the side, which is 400, then we could actually tap on our knowledge for sine rule. Okay, and from here I see that 74 degree is with 400. 65 degree is with my BC that we are supposed to find. Yeah. So for part A, you can then see, since we are going to find the length, I'm going to have apply my sine rule, BC over sine 65 degree. This is equal to 400 over my sine 74 degree. And from here, I would then be able to get my BC easily. Okay. So my BC will be equals to 400 over sine 74 degree multiplied by sine 65 degree. And this will give me a value of 377.133 to 6 significant figures first, followed by final answer. Three significant figures. Alright, that will be 377.133 Part B. Find the shortest distance of C to the line AB. Okay. So for this particular question, then I would then have to tap on this diagram. So I'm going to just, well, so for part B on about the shortest distance, this is what I'm going to do. So for part B, I'm going to do it part here. I'm going to do it here, okay? And at this point, right, I would just want to paste the diagram again. Now, what exactly is the shortest distance? You might wonder, okay? So, at this point, it's important to take note that for shortest distance, it is in fact the perpendicular distance. Since we are talking about the shortest distance of C to the line AB, then this particular distance is the 90 degree to the line AB. So it is actually a perpendicular distance, okay? So once we ascertain that, right, I am going to let D be the shortest distance. Oh, I saw that there's an extra D here. I'm going to hide it away. Okay. So once I have the D to be the shortest distance, right, then we can then really focus on this right angle triangle here. And previously, we know that the bearing here is 0 for 1 degree. We got the angle here. We also learned that from part A, the length BC is 377.133 meter. And so, to find the length of CD, I would then tap on my knowledge of Tuakaso now. With reference to the angle 41 degrees, BC will be my hypo, CD will be my opposite side. So with O and H, I am going to use sine ratio. So sine 41 degree will be equals to opposite over hypo. Then from here you can see that all we have to do is to multiply 377.133 to sine 41 degree in order for us to find the length CD. And from here, I will be able to gather that CD will be equals to 247.422 to 6 significant figures, followed by final answer 247 to 3SF. With that, we have come to the end of this particular question. So if you like this video at any point of time, do give it a thumbs up. And really, thank you for watching and have a nice day.